All right, the question got asked to me before, what are we doing today? First, let me just show you this, and I'm not picking on anybody. Tony's first here, so today is day 17. I have to do this every day where I have to come in and take attendance. After or on day 20, all right, so tomorrow's 18, Friday's 19, Monday's 20, okay? That means a quarter of the semester is done. Every 20 days, I have to go in and I have to come in, and for each one of you, I have to give you one of these work ethic grades. All right, so grade book, there's all your names, and basically what I have to put in there is meets expectations, does not meet expectations, exceeds expectations. All right, and you will get that grade next Monday. Also next Monday, and again, like I said, I'm not trying to pick on anybody, so I'll do it from the other end. And I'll just come in here and I'll use Andrew because I think he's at the other end of the spectrum here. So I will print out a copy and it'll say how many days we've had class, how many times you've been absent, how many times you've been tardy, etc. All right. I will also print out a listing of, I'm not going to show that on here, of your grade right now. So it'll have all of your grades that are on there. So it'll give you a chance to ask me any questions that you have. It'll be one-on-one. Normally I do it in the room, the conference room over there. I don't think we're going to be able to do that because for whatever reason, be it right, wrong, it doesn't matter. It appears as though some of the automotive guys have kind of made that their room, and they're starting to teach in there. So if that's the case, we'll just go into my office, which is literally right next to that, and we'll go in there. And I'll bring you in one at a time. So I just typically do it in alphabetic order. So I'll say, Tony, okay, you're done. Can you ask Ryan to come in, etc. All right? And that's your time. So if you've got questions on anything, if there's something you don't understand, if there's something that you don't like about the way the class is going or whatever, it's your chance to say something. The only other thing that I wanted to mention to you, and I know I've said this to you before, all right? One of my students, Ethan, has volunteered to tutor. If you think you might want to be tutored, Ethan is willing to come in here whenever we have lab days and sit down and work with you one-on-one. If there's something that you're not understanding, let's say that you understood everything so far, but you're having a problem with arrays, all right, then let me know that. Now, he hasn't filled out any of the paperwork yet because no one has said they needed a tutor. But if anyone here does, and there's no cost for you to be tutored, all right? And if it turns out, let's say that, you guys can't, oh, I really want to be tutored today, but, class is over, whatever. He's willing to work with people electronically also if you send him your code. It's harder to do that, but I've had people tutored electronically before. If you're interested, just drop me an email and say, I'm interested in having a tutor. I will tell you, Ethan's very soft-spoken. He's really smart. He's gotten A's in the first 3 classes he's taken with me, and he's got a strong A going right now. All right? He's very patient, too, as far as a hell of a lot more patient than I am. All right? So what we're going to do today then, starting right now, is we're going to go over Chapter 8. Once we go over Chapter 8, and I asked you to do this last time, so you still can if you want to. At the end of Chapter 8, we'll do the review questions and we'll do the test review. All right? After that, we're going to take that calculator program and add some stuff into it from Chapter 8. All right? Just so you see that. After we do that, I'm again going to assign, it's about 4 problems at the end of the chapter. Don't worry right now about what they are. You'll have plenty of time to write them down and whatever. But there are four of them, again, and the debug exercises. One of the 4 we're literally going to do as a class, just so you can see how this stuff works. All right? So again, that'll be your chance, if you have questions, to ask. So Chapter 8, if you're following along in the book, we're on page 311. I don't want to read these to you. This chapter is kind of a prelude for the next 2 chapters for 9 and 10. In particular, when we talk about things like overloaded methods. All right? So far, we've worked with parameters but the stuff we've done with parameters has been very, very simplistic. There's other things that you can do with parameters. You can have what are called ref parameters. You can have what are called out parameters. You can have what are called parameter arrays. Between that and overloading, that's most of the chapter. All right? Again, I would strongly suggest, as we're going over this stuff, if something doesn't make sense, again, I believe there's at least a couple of the you do it exercises in here that you might want to take a look at. All right? So, they mentioned that in the last chapter we learned to call methods, pass arguments to them, and receive values back from them. In this chapter, we will expand the method handling capabilities to use more sophisticated techniques. All right? So far, everything that we've done, for instance, yesterday when we had that calculator program, and we passed number 1 and number 2, if we pass both of those into our sum routine, those are called mandatory parameters. Because if we don't pass them in, we get an error message. Not only can you have mandatory parameters, you can also have what are called optional parameters. With an optional parameter, you're going to see that in just a few minutes. If you don't provide the parameter, one is provided for you. I think I gave you this example toward the end of class yesterday, where if we were writing a program where I told you to pass in your first name, your last name, and the state in which you live. All right? I might have 3 parameters, but the state one I might make optional, and I might say state equal double quote MO double quote, which means that if you passed in just your first name and just your last name, it would default to Missouri. But let's suppose one of you lives right on the border. Let's say you live in Illinois. Well, you wouldn't want to do that. So if it's Jesse, he'd want to say Jesse for the first name, Moore for the last name, and IL for the state. Does that make sense? All right, so we'll take a look at that. There are times when having a default parameter can make it a lot easier for you. But if you're going to use a default parameter or parameters, there are rules that you have to follow. All right? So there's different kinds of mandatory parameters. We have not yet looked at reference parameters. We have not yet looked at output parameters. We have not yet looked at parameter arrays. We have looked at value parameters. One thing I want you to understand, and this may sound real simple, and if it does, you know what? That's a real good thing. And if it doesn't, then hopefully when you think about it, it'll make sense. But if I'm sitting there and writing a program, all right, I was playing around with some other stuff this morning, but let's say that I come in here and I write a program, and I'm not going to write a whole C program. All right, you know, just a static, I don't remember, I think it's a little less, but I don't remember, void main. And let's just keep it like this. We'll keep it real simple. And I'm going to come in here and I'm going to say int x equals 75, int y equals 25, int z equals add 2, and we pass it x and we pass it y. All right, you saw something like this with what we did yesterday. Then we come down here and we say static int add 2, int n1, int n2. This is just some review from yesterday. Return n1 plus n2. Now, stuff you should know from yesterday. We talked a little bit about the word static. And static means you don't have to have the name, you don't have to put down the name of an object. If you say, I don't know what objects are, that's what chapters 9 and 10 are about. All right? This says that the method is named main, it has no parameters, and it returns nothing. Here there are 2 actual parameters, one called x and one called y. Now, we didn't go over this yesterday, but what I want you to understand is when we do this, literally what happens is the system does this. Okay? We say x and y, the system grabs their numerical coefficients. So that's what the system does. And if you go, well, that makes sense. Good. That's exactly what should happen. All right? And when it sees this line right here, it actually replaces it with that. And if that makes sense, that's good. These are called value parameters because it copies the value that the parameters have. All right? Everything we've done and we did yesterday were value parameters. And I want to mention this to you because sometimes this confuses people. All right? So if I came through here and in here, I came in through here and I said, you know what? N1 is equal to 10. N2 is equal to 10. Let's make it 15. All right? And now we return N1 plus N2. Now, if we do that, and we get down, and let's say in the next line that's right here, we were to write out the value of Z, it's going to be 25. All right? We are not changing these values. We are changing the copies that we pass in. When you pass something in by value, any changes you make in the method are temporary changes, and the stuff reverts back. All right? So, what if I wanted these to be changed? You understand what I'm saying? I want there to be a permanent change here. In other words, I want to be able to change this to 10 and 15, make this 25, but I want these to also change to 25. You understand what I'm saying? I want them to permanently change. Then I have to do this. I don't remember if it's ref int or int ref, but it's one or the other. We'll see it in just a second. Then that ref means reference, which means the address in memory of where it lives. It means I want to make a permanent change. So if we do this, this now becomes 10. This now becomes 15, which makes this 25. All right? So when you pass by value, the way that we did it yesterday, you're working with copies. Anything that you do in here is only working with the copies of those values. If you want to change it permanently, you instead of calling it by value where you work with copies, you call it by reference where you pass the address of it. All right? So keep that in mind because that's two of the things that they talk about in here. So again, when you use a value parameter, all right, you're passing a copy. I don't know any other way to say it than that. They show you this pictorially. They do the same kind of thing that I just mentioned to you. They've got X. They say that you're in X, so they should say in main, X is 4. Then we call display value. They reset X to 777, and then they say in method, X equals 777. But when you come back again, it says in main, X is 4. Because the one where it says in method, we're working with a copy of X. It's not X itself. All right? It is not, really, it should never happen where you do something like this and you have to change the value temporarily like they're doing here. All right? That probably will very rarely, if ever, happen. But the thing that to note is that, again, you are working with a copy. So any changes you may make, you are making to the copy. All right? All right. Reference parameter I've already shown you. I'm going to show you output and parameter array in just a minute. Now, this is one of the things that's on the test. I don't remember how or what, in what way, but they ask the difference between reference parameters, output parameters, and parameter arrays. They ask what the differences are. When you work with a reference parameter, you use the word ref. That's one difference. When you work with the output parameters, you use the word output. I'm sorry, the word out. And when you use work with parameter arrays, you use the keyword, it's param or params. You're going to see all these in just a minute. That's one difference. Okay? When you work with a reference parameter, all right, you must have an assigned value. It already must have some kind of a value or it won't work. When you work with an output parameter, you typically don't have an assigned value. And when you work with a parameter array, you can pass one thing, two things, or any number of things. If that stuff doesn't make sense to you, you're going to see every one of these. in the two programs that we're going to do at the end of the chapter. All right? So there's the ref. So notice it's the same thing they showed before. But now when we're calling this, we're saying ref x here and ref int number here, so we're permanently changing it. So this will say in main x is 4. Then in here it'll say in method number is 888. When it comes back to here, it'll say in main x is 888. So when you want to permanently be able to change something, you put the word ref before it. When you pass it, you put the word ref before it inside of the method too. All right? And that's exactly what they're showing you right here. Now, I'm not saying, hey, does that totally make sense? All right? But I'll tell you, if it's going to get harder. 8, 9, and 10 are probably the 3 hardest chapters in the book. If you've skated by right now, maybe when I say skated by, maybe that's not fair. You say, oh, I got an A, and I haven't read the frickin' book once. All right? That doesn't make me happy. I've had people in the past say that to me. Well, your lectures are good enough. No, they're not. There's stuff in the book that we just don't have the time to cover. So if this doesn't make sense to you, you should definitely, all right, be reading through the book. The book's not a terrible read. She's not a bad author. All right. Now, what's the difference between a ref and an out parameter? With an out parameter, like the example that they give here that's on page 316, notice we're passing first and second. They don't have values. Everybody see the example up here? First and second in that line that's in gray, they do not have values. Out means that we're going to set them inside of the routine. All right? And they'll be permanently changed, but the difference is when we did ref, it must have a value. If we have out, it doesn't have a value. Other than that, they work similar to one another. All right? So this is what we're going to use for our calculator program. We're going to call that input a number thing that we did yesterday, and we'll pass number 1, then we'll call it again with number 2. We'll pass them both as out parameters. And then we will set them in here, and they'll be permanently set. All right? Then we'll pass sum, and we'll pass difference, and we'll pass product, and we'll pass quotient. We'll pass those in as ref parameters. So you'll get a chance to see both of those in action. So the author tries on the top of page 317 here to give you what she considers to be, some words to the wise, whatever you want to call it. It says, if you always have an initial value, use ref. If you do not have an initial value, use out. Sometimes it may not matter, all right? But again, if you already have initialized the variable to something, you really should use ref. If you have not yet initialized the value, what do I mean? If I say int age equal 21, in fact, maybe I just initialize it to 0. Int age equals 0. Then I want to pass it as a ref parameter. But if I just say int age, I want to pass it as an out parameter. All right? It says in summary, when you need a method to share a single value from a calling method, you have 2 options. Use the return type and pass by reference. What I'm going to do when we start is I'm going to take 5 minutes to go over that program we did yesterday. Then we're going to start making changes to it. Again, I'm going to ask that you make the changes, but I do have hard copies for you. That said, please do it anyway. You learn by making mistakes. Anybody who thinks, yeah, why don't you just give us hard copies of everything we do in here? Then you're doing data entry. But if you're keying stuff in yourself and you're looking at it and making mistakes when you're doing it, that's when the learning's really taking place. All right, or as you'll see today, we can pass by reference. When they say reference, they mean the address in memory of where something exists. All right? And they mention the Tryparse. We're going to go back, and I don't know if I've done a good enough job of explaining the Tryparse to you. So we're going to in version 2 of this calculator set it up that it'll say enter a number. If you just put nothing there and hit enter, it'll say error, must be numeric. Enter a number. or if you put hello in there or whatever. We'll do that with a Tryparse. All right? You'll have that in just a bit. The Tryparse, as it says, requires the receiving variable to be an out. That's what that out thing means that we've dealt with before. The argument does not have to have a value assigned previously, and the method returns a Boolean. Tryparse returns true if the parse worked. So what that means is typically you're taking something in a text box and you're trying to convert it to a number. If it worked, if I put it in result, if it worked, result is true. If it didn't work, result is false. All right. Next are parameter arrays, and these are kind of screwy to people. It's kind of hard to understand. All right. Well, what if I created a routine that was going to be called I'm going to print your name? That's the stupid name, but I'm calling the routine I'm going to print your name. And you've got your choice. You could pass to me your first name, or your first name and your last name, or your first name and your middle initial and your last name, or your first name and your middle name and your last name, etc. So you could give me a variable number of parameters. If you do that, you use what's called a params array, like they show right here. So in this case, we could set this up where we could pass in a single string, or we could pass in 2 strings, or 3 strings, or 1,000,000 strings. All right? So params means that you can have a variable number. You can call it several times. In the program that I'm going to ask you to do, and we're going to do as a class in just a few minutes, it's called averages. And they tell you to pass in 1 number, then 2 numbers, then 3 numbers, then a whole array of numbers, and go through, and each time you do it, figure out what the average is. Well, if we pass in 1 number and it's 26, pretty easy to figure out the average, right? It's 26. We pass in 2 numbers, we have 26 and 50. We add the 26 and the 50, that's 76. We divide by 2 and it's 38. Then we'll do an array of about 8 numbers. And all those numbers that we put in will randomly generate them. So every time we run the program, we'll get different results. So they show in here, again, this is a good example. Since this is a parameter array, they call this once and just put in 1 name. So you get Ginger. They call it again and you put in 3 names. So you get the 3 names right there. They call it again and they pass in the whole array. So you get every name. So again, the params is good. It's good to use when you have a variable number of arguments, when you don't know. All right? So let's say that in here, let's suppose that I give 10 tests. And Evan misses 1 test, Matthew misses 2 tests, etc. So I could do that. I could figure out their averages, but if I figure out Matthew's average and he hasn't taken those 2 tests yet, I don't want to give him zeros because that's going to really skew his average. All right? So I could call his maybe with 8. All right? I could call Evans with 9. Maybe Andrew took all of them. I could call his with 10, etc. A variable number. So again, there's a you do it here that starts in the book on page 322. All right, again, it's a swap program. What does that mean? It shows you how you can swap 2 numbers. So the idea is first is equal to 34, second is equal to 712. Then after you call swap, now first is equal to 712 and second is equal to 34. So you'd flip their values. Okay? And it's not hard, you just do it like this. So they show you the before and the after pictures right there. Not much code, but again, I think this stuff is really helpful in you understanding what's going on. All right? Now, it says a method's name and its parameter list constitutes the method signature. So in other words, that's the method signature for main. That's its name, and it doesn't have parameters. here's the method signature for this. So its name is display with border, and its parameter is a string called word. That should make sense. All right. But what I can do with this, let me try to show it to you this way. I showed you before this. Okay? Am I right in assuming that if we're not going to jack around, no refs, no nothing, just X, Y, return X plus Y. Am I right in assuming, whoops, am I right in assuming here that what's going on there, that makes sense to everybody? Okay? Well, if I do this, and I put in string fname equals Jeff, string lname equals Scott. All right, then I come down here and I say string full name equals add to fname lname. I'm going to get an error message when I do that, because it comes down here and it says what you're trying to do is you are trying to take two strings and take a string and put that into here, take a string and put that into there. That makes no sense. Understand that? But what I can do is this. I can say static string add to string n1 string n2, and maybe I want to add this, but I want to make sure there's a blank space between them. All right, so now calling it the second time here, let me hit enter a couple times. All right, now it's expecting, it says, oh, I'm going to call this, and that's a string, and that's a string. So that's going to return Jeff plus space plus Scott. Does that make sense? This is what's called an overloaded method. The method names are the same, but what goes in the parentheses is different. Most sophisticated programming languages allow you to do some form of method overloading. Okay? And it's just something that you have to get used to. I can't put it to you any other way. It's just something that, again, most languages allow you to do. I could have another one here if I wanted to, where this was a double. And let's say that this was a double, and this was a double. All right? So now I could come in here and say double A equals 10.8, double B equals 11.6, double C equals add to A, B. So now I've got three different versions. There's an add to with doubles, there's an add to with strings, and there's an add to with integers. So I've got this in here, and I've got the original, and I've overloaded it twice. You can overload things as many times as you want, but this has to be different every time. Okay? And I'm going to tell you this. This may or may not make sense to you, but I'm hoping it does. The compiler, the thing that runs your program, it makes it work, doesn't care what these names are. Doesn't care that this is N1 and N2. It says string, string. So what the compiler looks at is this expects 2 ints, this expects 2 strings, this expects 2 doubles. It does not care about the names. The names are done for you. The first thing the compiler does when it starts to compile your code is it makes sure that there are memory addresses associated with these variables. Then it doesn't even use the variable name. And it gets rid of all the white space you have in the program because it doesn't need it. So things like variable names and white space are done for you, not for the compiler. All right? So they do show some examples in here. So earlier they showed that display thing, and that's display with border where they've got a string in here. So when you do it, I don't know if they showed it in here or not. No. But you could put asterisks in, for example, there. Then they go over there and they override it, and they do one with numbers. All right? And if we wanted to, we could call it twice, and one time we could put strings. I guess that's what goes in here. One time we could put numbers. We could do it any way we wanted to do it. So it says methods are overloaded correctly when they have the same identifier, so the same name of the method, but their parameter lists are different. All right? And that means that either the number of parameters they have or the order of them is different, or the types or whatever. And it really doesn't matter, to be honest with you, which one of those it is. But if you don't do that and you make them the same, the system doesn't understand. All right? The computer isn't smart. So if there were two people in this room named Jesse Moore, I could tell the difference between them. The computer couldn't necessarily tell the difference between them. But if we said, oh, you're Jesse, I don't know what your middle initial is, let's say it's J. All right, if you're Jesse J. Moore and then you walk in and you're Jesse M. Moore, all right, then the computer could tell the difference between you because of those. Or if you're Jesse Moore and you're Jesse J. Moore, it could tell the difference between those. All right, that's the kind of thing that we're talking about in here. All right. Okay, it says when a method could execute multiple overloaded versions, like we just looked at right here, the system figures out which one to call based on did I pass in ints or strings or doubles. There's a term for that. It's called overload resolution. I'm telling you that because it's on your next test, or you're on your Chapter 8 test. So as they mention here on the top of page 329, C# determines which method to execute using a process called overload resolution. And it does that by just looking at, oh, these were two ints. Oh, these were two strings. Oh, these were two doubles. They don't have to both be of the same type either. One could be a string and one could be an int. One could be a double and one could be an int, etc. All right? We talked about this conversion table a long time ago. We've looked at it more than once, so I'm not going to go through it again. All right? Now it says here that C# has got its own built-in overloaded methods. Maybe you did this, maybe the first time, or maybe you've noticed it before when we do those conversion functions and you type convert.to. It shows you a whole bunch of different things. 2int32, 2 double, 2int16, etc. To char or whatever, to boolean, to byte. Those are all overloaded methods. All right, that's what the author is talking about here. There's another you do it that goes through overloaded methods, and that starts on page 331. All right, it's on 331 and 332. Again, you're probably typing in a grand total of about a dozen lines of code. So if it doesn't make sense to you, please go back and take a look at that. All right, ambiguous methods. The computer doesn't allow itself to be confused. Typically, if it's confused, all right, at best, it'll try to do what it thinks is right. Sometimes that might be right, sometimes it's not right. Sometimes when the computer is confused, it doesn't do anything because it doesn't know what to do. All right, so what do we have here? We've got three different versions. Notice int, double, double, int, int, int. When the system is confused, we just looked at this. We talked about those conversions, wherever the heck it was, that the computer does. It's easy to confuse the computer. Again, the computer has the intellect of about an 18-month-old child. All right. When it's confused, when you set it up in a situation where it's confused, you do typically doing it by what are called ambiguous methods, where the system can't figure out what it is you're trying to do. And if it can't, in this case, it'll probably give you an error message that says the call is ambiguous because it doesn't know what it is you are trying to do. All right. It says an overloaded method is not ambiguous on its own. It becomes ambiguous only after you create an ambiguous situation. And how do you do that? It's a practice where you learn it. All right. Again, if you notice here where it says watch the video, all right, and I gave you her website at the, it's in your syllabus, or else it's on the main page. And inside Rankin, she even has her own little 5-minute videos on what this stuff is about. And if it helps to look at her stuff as opposed to listening to my examples, go for it. All right. Optional parameters, and that's on page 335. We really don't have much left here in the chapter. We're on 335, 2, 3, 4, 5, 6, 7, 8, 9, about 9 or 10 more pages. We'll finish this, and then we'll take a break. All right? So as it says, sometimes it's useful to have an optional parameter. I gave you that example where I use state in here. Okay? Now notice they've got a thing in here where you can pass this in length and width. You can either pass in 3 parameters or you can only pass in 2 parameters. If you pass in 3 parameters like 4, 6, and 8, the 4 becomes the length, the 6 becomes the width, the 8 becomes the height. If you pass in 2 parameters like this, the 4 becomes the length, the 6 becomes the width, and the height is 1. If you use, these are called optional parameters. If you use these, they must appear at the end of your parameter list. You must put required parameters, then your optional one or ones on the end. You never have to have required parameters. You also can set it up that everything is an optional parameter. So you could do anything in between that, where everything is optional, nothing is optional. All right? And again, 4 times 6 times 1 is 24. 4 times 6 times 8 is 192. All right? So they give you some examples here of working with optional parameters, and then they tell you what you can do and what you can't do. This is valid because the optional parameter is at the end. That's invalid because it's not at the end. This is valid. They're all optional, but that's okay. This is valid because none are optional. And this is invalid, all right, because you've got the default one first, then a non-default. So in other words, if you put this int b before the int a, it would work. And they give you some rules here. It says if you omit an argument, you must do one of the following. Leave out all unnamed arguments to the right, or just use named arguments. And if you go, that's really frickin' confusing, then don't use them. Period. Just don't use them. All right, until they make a little bit more sense to you. And again, they show you on the bottom of 337, it says, for example, assume you've declared a method like this. It's valid because we've got a required parameter, optional parameter, optional parameter. Then on the next page, they show you method calls to this that are either valid or that are invalid. And they explain why they're valid or why they're invalid. All right? The last thing that's in here, I think it's the last thing, and this is on page 338, and that's what's called using named arguments. All right? It says, for example, assume you've declared a method that looks like this. It's called method 2. It assumes you're passing in an int, a char, an int with a default value, and a double with a default value. All right? Again, they show you things that you can do and things you can't do. All right? What they're doing here, that's a named argument. They're letting you know that that's D and that's its value. Typically with beginning programmers, they find this very confusing. So again, I'm saying, then don't use it. I'm not going to require you to use that at all in here. All right? And this morning, I don't know if it's funny isn't the right word, but this morning I was going in and I've been taping some stuff for fall. And I came in here and I was doing this, and I did this index file, and I started to go in and do a bunch of stuff in here with JavaScript. Well, this morning was one of those mornings, and we all have them, when I kept getting brain farts. I'd start doing something, and all of a sudden something wouldn't work. I left parentheses off, or I just called something the wrong way, or whatever. All right? But what I'm telling you is those to me, those are some of my best lectures. Because when people say, well, you know how to do it. No, I screw up all the time. And I always leave those lectures out there. But what I'm saying is the way for you to learn this stuff is to just write yourself a program. Start making changes to it. Not necessarily a program you're turning in, but just try to do something and see if you can do it. You're going to learn a lot more by doing that and making errors than you are by just listening to me. All right, and having us key and code together. All right. When you use these names like this, so notice here's an example. That's a named argument. You're letting the system know that name is the value, and it's got this. Your programs become more self-documenting. We've talked about this before. All right. There's advantages and disadvantages to using those. I'll let you read that. All right. You may or may not even agree with what the author says. Okay? So let's jump quickly and look at the review questions, and then we'll take a break. So if you have your books available or you write it on paper, however you do this, I'm on page 345. All right? So here's your review questions. Number 1, a mandatory parameter. The answer to number 1 is C. Requires an argument to be sent from a method call. So number 1 is C. Number 2, which is not a type of method parameter in C#. The answer is C, forensic. So number 1 and 2 are both C. Number 3, which type of method parameter receives the address of the variable passed in? The answer to 3 is B, a reference parameter. So CCB for the first 3. Number 4, when you declare a value parameter, you precede its name with A, nothing. So CCBA for the first page. Turning up to page 346. Number 5, it says back in main, what happens? Well, notice you made that a ref parameter. That means you're making a change to it. It started with 100. You add 25 to it. 125 is B. So number 5 is B. Number 6, it's not a ref parameter, so you're working with a copy. So when you get back, it retains its original value of 100, which is A. So 5 is B, 6 is A. Number 7 is one of these questions that the author puts in here that I think her wordage sucks, for lack of better words. But I'll tell you what I think the answer is. So number 7, I think, is C. A reference parameter requires an initial value, and output parameter does not. So I think 5 is B, 6 is A, 7 is C. Number 8, a parameter array, the answer is C. Both of them are true. All right? It's both declared using a keyword params, and it can accept any number of arguments. So 8 is C. 9, which of the following method calls is valid? Since we made it a params, all of them are. So number 9 is D. All of the above are valid. Number 10, correctly overloaded methods must have the same A, return type. Please don't say C, parameterless, because that's what has to be different. Number 11, methods are ambiguous when they C are indistinguishable to the compiler. Remember, the compiler is the software tool that takes your C# code and it converts it to the zeros and ones the computer can understand so it can spit the stuff back at you. So number 11 is C. Number 12. Which of the following represent correctly overloaded methods? And I believe that A is correct and B is correct because they're both different. Now, C is incorrect because they're the same. So the answer I put for 12 was D. Two of these are correctly overloaded methods. Number 13. Which of the following pairs are correctly overloaded? The answer here is B. 13 is B. A is incorrect because they're both ints. C is incorrect because they're both ints. So 13 is B. Number 14, the process of determining which overloaded version of a method to execute is also known as overload D resolution. 14 is D. 15, when one of a method's parameters is optional, it means that A, a default value will be assigned to the parameter if no argument is sent for it. Number 16, which of the following is an illegal method definition? 16 is B, because we've got a default before a non-default parameter. All right. 17, which of the following is a legal method call? The answer is C, because the first one is an int and the second one is a double. 17 is C. 18, which of the following is a legal method call? Every one of them has a default parameter, so the answer is A. 19 and 20, I'm not going to answer because I think that the questions just suck so bad I didn't know what she was asking for. I did it twice and I got different answers both times. Again, if she ever puts questions like that on a test, I throw them out. All right? As far as your homework, if you look on page 349, you are to do numbers 2, 4, 7, and 10, and the debugging exercises. And if you look, this one right here, right there, we're going to do that one as a class. So you will just have to do 2, 4, 10 and the debugs. We're going to do number 7 as a class. So it is 8:56. We're going to come back at 9:10. When we do, please open up the Word document I sent you for the Chapter 8 test review. We'll go over that. I'll give you those answers. All right. Then we're going to go and make a copy of our calculator program and fix that, so to speak. And then we're going to write number 7. In an ideal world, we'll be done around 10 o'clock. It might be a little later than that. Let's just see how it goes. All right. So please, let's come back at 9:10.